Hello, my name is Bruno, and this talk is about Istio. Istio is what I've been waiting for in the sense that for so long we've been talking about some of the basic primitives and semantics about clusters, about Kubernetes. Istio starts talking about some of the higher level of abstractions that enable microservice architectures. Most of the world is transitioning from monolithic applications. These monolithic applications are being broken down into microservice architectures. The challenge, however, is that as you break your application apart, you don't want to have to make special modifications for some simple things you would want to do with modern applications. What this means is that I don't want to modify my application to just support service discovery, load balancing, failure recovery, metrics, and monitoring. And I may even want to start supporting such things as A/B testing, canary releases, rate limiting, access control, end-to-end authentication. All of these things I want to be able to do without modifying my architecture, my applications themselves. I don't want to have to recompile them. This video is one of several, and to kick things off, we'll just quickly go over what is Istio. I'll let the audience here do their own research. I'll just show some basic resources. Setting up Istio, there are a number of components here to get installed so that you can use the product. And then we'll set up our sample app, which by the way has no direct links to Istio, but it will be used to explain all of the topics having to do with Istio. Now to begin, Istio is simply a way for us to connect, manage, and secure microservices. As we talked about before, it will do load balancing, service-to-service authentication, and more. Istio works by way of a sidecar, which is a sister container that will run inside each of our pods and will behave as a control plane. This control plane allows us to intercept all network communication. This is the communication happening between microservices. And the word service mesh is often used to describe this network of microservices. And the role Istio plays here is that it helps out with the interactions among the different microservices. So this is what Istio architecture looks like. The important thing to notice here is that in service A, where we have our pods running of our application, a sidecar container is running. That's the envoy part you see here. Envoy is part of the control plane. And it has three components: a pilot, a mixer, and the authentication for Istio. If you look at the details of Envoy itself, you'll see the actual code that is used to kind of add to the components of the container here. You see the Docker file in front of you here. You see the copy commands for pilot, for the authentication, and for the mixer. As we said before, Envoy runs as a container inside every single pod. Think of it as a high-performance proxy written in C++ that mediates all inbound and outbound traffic through the services. That means that all traffic that ultimately gets to pods has been processed through Envoy. Envoy provides dynamic service discovery, load balancing, TLS termination, support for HTTP2, and gRPC. And if that's not enough, circuit breakers, health checks, stage rollouts, and a percentage of allocation traffic splits based on a percentage you specify. Fault injection, and of course a bunch of metrics by way of Prometheus and a couple other tools. Now I'm not going to go into great detail here for the next three, but Mixer is there to enforce access control and the usage policies in the service mesh. It also collects telemetry data from Envoy and other services. Pilot's all about service discovery for the Envoy sidecars, traffic management, routing, etc. And of course, Istio Auth, as it sounds, provides strong service-to-service authentication and mutual TLS. Now the place we're trying to get to here is the namespace Istio system. You can see here that the replica sets really define the services also map to these pods, and the pods, of course, are composed of containers. Now the functionality, of course, of Istio is defined by all these running pods. There's 9 of them here. Let's go through them real quick. The first container is Pilot. Pilot will be here for service discovery, traffic management. It also plays a role in A/B tests, canary deployments. Istio-CA is all about the service-to-service authentication using mutual TLS. You'll see the proxy debug twice for egress and ingress, and of course this is the envoy process itself. It runs in each pod. To be accurate, not a process. It is a process as well, but really it's a container that is running inside each of the pods, and it acts as the reverse proxy, the layer 7 load balancer, if you will. Now, Grafana is the visual dashboard that lets us look at performance metrics. It's typically bundled up with Prometheus, and of course is one of the running containers. Now, the stats exporter here is all about running on each of the nodes, each of the agents in the cluster in Kubernetes. It essentially exports all the performance metrics outside of a port that Prometheus is listening on. And of course, Prometheus is the one that's aggregating results and then making them available to Grafana. Okay, Service Graph is nice because it gives us a web-based interface to let us look at the relationship between the different services. It lets you really see which services are tied to what other services, so you get a visual picture of what's calling what. Zipkin is for doing tracing. So this is great for troubleshooting in a distributed architecture. It's generally very difficult to track what is really happening as services call each other, and this particular component, Zipkin, makes that far easier. So here, for example, you could see the product page ends up making calls to reviews, different versions of reviews, and also looking at the requests per second gives you some idea of which are the most active or hot spots here. You can see it filters down, and you can see it's calling MongoDB ultimately, but this just gives you a little bit of a visual clue about what a service graph might look like. Now, the point here of Zipkin, as you can see, is to really look at how long different service calls are taking. And it's a great way to find the bottlenecks in your distributed application. What you're looking at here is the Grafana dashboard. It's communicating with Prometheus. It provides some pretty decent monitoring. It lets you really take a close look at the different metrics for different applications running within the cluster. Let's go about the business now of installing Istio onto our Kubernetes cluster. The implication here, of course, is that you do already have a Kubernetes cluster that you can work with. And so let's follow some steps here in the quick start guide in getting set up. To learn a little bit more about what gets deployed here, let's go to the Kubernetes site. Let's go to charts. This is where Helm stores all its information here. We'll go over here to Incubator because that's where Istio can be found. We'll drill down to Istio. We'll notice a few things here. We'll go a little bit further here into the templates folder, and here's where we can start looking at these YAML files that make up the Istio deployment. Okay, so as we drill down here, you see all the various YAML files. You can kind of drill down deeply if you want to know more. Let's go back up to the base folder here of Kubernetes, go back into charts, and show you some of the add-on services that are there, the Grafana, the Prometheus, and so on. So we'll drill down a few levels here into Incubator, Istio, templates, add-ons, and deployment. We're talking about the add-ons here. Go into deployment, and you can see, sure enough, the other components we talked about. So let's look at some installation scripts. I've got a little bash script here that will do it for us. Notice I've got an Helm install. It will install the Incubator Istio code, and then we do a Helm upgrade. So let's quit out of the editor here, go back to the command line, and issue the bash command to run this installation script. One of the things you'll notice is that I've done this before, and so basically you're going to get a little bit of an error, but that's fine. Helm can be reinstalled over and over. It will just go to the state that's desired regardless of what's there already, with some exceptions, of course. So this will take a few moments. When we're complete here, all those components we talked about will exist. We'll want to put Istio in the path so that when we run the Istio CTL utility, it will execute properly. Let's go and look for the various text messages here, and notice the status at this point is deployed. So we do have some success. You might want to pay attention to some of the other services that have been exposed. Notice we have an ingress here of 13.64.65.34, and that kind of concludes the basic installation of Istio. Now, of course, the app isn't installed. That comes next. So we talked a little bit about what Istio is. Let's take the next step and really show you how to install the Istio CTL utility. We will need this utility to deploy our book info sample application. It is this utility that will install Envoy as a container in all the pods, among some of the other capabilities that the Istio environment provides. The command to install the Istio-ctl utility is quite simple. You can see this on the Istio site. There's a curl command here, get latest Istio. You can see the download taking place here and the appropriate folders being created, and now it's a question of just setting up the path correctly. And to set the path correctly, we're going to do that in the bashrc file. So let's go to the root folder, use vim to get into bashrc. We'll go over here to the bottom, and you can see already that I've done that. You'll notice, for example, on 139, I set an environment variable for the path of Istio in the bin folder. And then here on 141, I go ahead and just include that environment variable as part of the path. Now, the ultimate command is to go ahead and issue that. But let's first refresh the path and then clear the screen and then do an Istio-ctl command, and we should see some help. So it's working. We've got Istio installed correctly. So one easy way to verify this is to use the dashboard for Kubernetes. So first go to kubectl proxy, set up that local host, and then we'll go back into a browser, go to localhost/UI. But you won't be done yet. You'll need to also go to the end of this URL and add a / for this to work. Once you do that, you can go check out your deployments. Make sure that Istio did in fact install. We'll go down here and perhaps look at some of the pods to make sure that they also deployed correctly. The deployments in fact look okay. Let's click on the pods menu selection, and sure enough, everything's there. So we've got Istio set up correctly. We've got all the pods, all the services in place. At this point, we need a sample application to work with. That sample application that ships with Istio is called Bookinfo. So as a next step, let's go ahead and install that. The Bookinfo is the sample app we'll use for the rest of these sessions here. So let's get that installed here. You can see that it's quite simple. Let's install it. Now the app is composed of a number of microservices. The first microservice, the main one, is product page. It calls the details and reviews microservices, and this is about books. So details is about book information, and reviews, of course, are the book reviews. Now to accompany the reviews is the ratings microservice. One of the important aspects of this example too are the versions that are available for each of the different services. So notice here, kind of halfway down, there are 3 versions of these applications. So we want to make sure that when we're talking about the rating service, we think about the various versions. Versions are important here in the examples because we may want to route traffic to different versions at different times, and they'll be essential here in the demos later. Now, in the spirit of a microservice architecture, each of the different microservices could be authored in a different language or environment or framework. Notice, for example, the requests come into Python. The Python product page is a web app. That web app might make service calls into the reviews, which are authored in Java. Now these reviews call into the rating system that might be authored in Node. And then finally, circling back to product page, we might call into a Ruby application called details. The key thing to notice here is we have a number of pods that make up our Bookinfo application. What you're going to find is that each of these pods are running the Istio proxy. That's that Envoy reverse proxy layer that acts as a layer 7 load balancer. Also notice that in this case, container 1 is simply the product page v1. That's the Python application. You can see the underlying image here. What I think is real important here is to look at the labels over here, because later on you'll notice, for the reviews part anyway, that these labels will play a role in routing the traffic to certain pods. So proper labeling is critical here with Istio because it's used by the underlying infrastructure to communicate among the different pods. Okay, let's turn our attention to the 3 review pods. Notice that they differ by version number. One version number here is in red, v1, purple for v2, and green for v3. Notice that each of these 3 containers also has the underlying image matching that version number. And again, very important here to notice the labels, because after all, as we have said many times here, the labels play a key role when we start to route traffic. When we do canary deployments, A/B testing, and so on, labels are crucial. Okay, let's wrap up with the last two pods here, details and ratings. Notice everything is V1 in this case, so no need to really worry about that. I will say that the important point to summarize here is that, of course, we have the correct image for each of these containers. The examples book info details V1 and examples book info ratings V1. Also, again, to summarize, we have the Istio proxy or the proxy debug image, which in fact really is Envoy. This Envoy proxy debug container runs in all the pods. Again, playing the role of the broker and communicating among the pods with other pods. Just to summarize again, too, the label is very important later. This metadata is used by the fabric, by the control plane and data planes to really glue together these different pods across all the services. So again, this summarizes all the running pods with respect to the demo app, the book info demo app. This is a very fundamental need as we move through the rest of these sessions. So now we're finally ready to actually do the install. So we're going to go to the samples folder, the book info, the cube, and take a look at the book info YAML file, which does the entire deployment of this app. Now the command to do that is kubectl create-f, and then we leverage the Istio CTL utility to do the injection using the kube inject command. And then of course we add this book info.yaml file. Let's go ahead and fix the extra space in the -f here and go ahead and do the deployment. Hit enter and you'll see all the services and deployments worked, all the review version numbers worked as well. The next step is maybe to go back to the portal and take a look here to make sure those pods did deploy. It looks like they did. Likewise for the services. And maybe just take another quick peek into bookinfo.yaml here to actually see all the different deployments and services that we created here. So here's that sample bookinfo.yaml. If we go search for the word kind, you'll see here the details service, the details deployment, the ratings service, and of course the ratings deployment version 1. And you'll see reviews, you'll see reviews version 2, and of course more. Okay, so now the real test is to go to the actual bookinfo website. Let's figure out the IP address of the gateway, the ingress controller. It's 1364.65.34. So we'll go over to a browser, hit that endpoint with the product page URL, and hopefully get our application. So I'll say 13.64.65.34/product page, hit enter, and hopefully we'll get the app. So we're good. This is success. A to Z, we're finished with this demo. So this video concludes the part of a longer journey where we explored deeply Istio. The point of this module was to really get into the installation, talk about the components of Istio, talk about the sample application that is the book info. We really took a lot of time to break down the different pieces, to show the services, to show the pods, to show Envoy, to show all the little components that make up the broader framework that is Istio. My name is Bruno Turkley, and thanks for watching.